Alright, hello everybody. Welcome back to the stream. I hope you guys can see this because I can't see it on my end in the YouTube studio thing. And it's going all crazy. Let me actually just test something real quick. I'm just going to see if I can watch it. Alright, seems okay. Alright, so I'm just going to get right into it. So today we're going to be working on creating a formal camera class that we will use to control the camera. We looked a bit into this last time where we created kind of an informal definition for a camera where we essentially created like the essence of the camera using the model view and projection multiplication to create that sort of effect. Let me just cue up the music real quick. Alright, and we go ahead and switch over to the desktop. And alright, so let's look at what we had last time. So at the end of last video, we had, it's going over here for some reason. So we had this one cube here, and I think we were able to control it using the W, A, S, and D keys just to see where it went. Yada yada yada. So that's all good right now. And that's all we had. But now, that's not too useful because we're usually going to have multiple different objects, and out in that space with the global space is independent of the camera. Really. So the camera should be calculated on its own, and then the view that we project on the screen will be calculated using both the model from the global space and then the model from the camera. So we're going to do some vector subtraction and addition in order to create that sort of thing. So let me just go ahead and pull up some of this code over here. So we're going to go ahead and create a new set of files, a new class in the folder IO. We're actually going to create two. So the first thing we want to do is create a class for the screen. So we're going to call it just screen.h and screen.cpp. We're not going to be working in the fragment or vertex cores at all today. So in screen.h, just go ahead and say if not defined, screen h, and define screen h, and if. Then we're going to have a class for this. So we'll just call it class screen, and we're just going to store a couple of static variables here. I just want to do this so that we can get as much out of the main class as possible. So we're going to have public members and static unsigned int screen width and static unsigned int screen height. And then we're going to create our frame buffer size callback like we have been doing with the keyboard and the mouse, where we set callbacks. So for the screen, we're just going to have a frame buffer size. So all it's going to be is static void frame buffer size callback, and we're going to say glfw window pointer window int width and int height, just like that. And then in screen.cpp, we have to include a couple of things first. So at the top of the file, just go ahead and include glad/glad.h and include glfw/glfw3.h, just like that. And make sure that they're in this order, because this order is really important. Because glad is there's a lot of stuff that glad does, and it has to be included before glfw. Alright, and then in the source file, we're just going to include screen.h. We're going to set our static variables. So we're going to say unsigned int screen screen width we set to 800, and unsigned int screen scr height is equal to 600. And then void for the callback. Now we'll just do void screen frame buffer size callback glfw window pointer window int width and int height. We're gonna do what we have in main.cpp, which is gl viewport. We just reset the viewport to 0 width and height, and then we just want to reset our static variables. So scr width is equal to width, and scr height is equal to height. So that is the screen, and now we can go ahead and include the screen header in the main file. So go into main.cpp, include the file wherever. So go include io/screen.h. You can also get rid of this frame buffer size callback if you won't be using that. And you can also get rid of these global variables width and height up here because we won't be using those either. Alright. And then we're just going to replace all our instances of screen width and screen height with screen so that's on line around 48 where we create the window, and then for the callback we need to set it to window comma and then screen frame buffer size callback. The callback, and then down here where we do the perspective, we have to set the aspect ratio. So we're just going to go ahead and just put the screen stutter, so when we run it, there's still like that, it still like stops moving. Like if I'm pressing W, it'll just stop. I don't know why that happens, but it just does. I have no explanation. Okay. Alright, so next what we want to do is we're going to go ahead and start our camera class. So in IO, go ahead and create a new class. It's going to be camera.h and camera.cpp. So camera.h and camera.cpp. In camera.cpp, just include camera.h. And then in camera.h, we're going to go ahead and remove drag on one statement. And then replace it with our classic macros. So if not defined, camera h define camera h and if. Let's put our include statements up top. So we need include glad/glad.h, glfw/glfw3.h, and then we're going to have two of the matrix include. So include glm/glm.hpp, and then also include glm/gtc/matrix transform.hpp. Next, fields. This is just here so that any class can access the default camera. We'll be needing that for the control of it. Alright, so that's all there. And now let's go ahead and create the non-static members in the public segment. Alright, so we're going to have a couple of different variables here. We're going to have a position, which is going to be a vector. So GLM vec3 camera pose. We're going to have now this is where it gets somewhat confusing. So in the camera, there are a couple of axes that we need to worry about. So there's going to be a right axis, an up axis, and a front axis. So that's kind of self-explanatory. The right axis is where the right is, so like pointing to the right. The up axis is just up, and then the front axis is where the camera is looking. And we could calculate that using vector subtraction, but we're just going to keep it as our own vector for now. All right, so position, GLM vec3 camera front, GLM vec3 camera up, GLM vec3 camera right. And then last, we're going to want to have an extra vector, and that's just going to say GLM vec3 world up. So GLM vec3 world up, and this is just going to be the up in the world. Because if the camera is tilted down, camera up is going to be looking straight, not up in the world. Like on the Earth, if you look down, the top of your head would be looking forward, but that's not world up. World up would be through the back of your head. So we need to create a separate variable for that. Next, we're going to have a couple of different variables here. Let me just... so with the camera, there are a couple of things here. There's pitch, yaw, and roll. I'm not trying to go in the accent for that, but yaw. Yeah, so the only two that we need to worry about of those are yaw and pitch. So pitch is the rotation around the x-axis, and yaw is around the y-axis. It turns out that you can find the rotation around the z-axis from those two. It's going to be used, you're going to do that with a little bit of trigonometry, because these are Euclidean, so they have relations to each other. So these are all going to be stored in floats. So we're going to float yaw and float pitch. Determine how much to pad the mouse component. And this is mouse sensitivity in all games. So, and then float zoom. This will be turned into our field of view, which we currently have as 45 degrees. Yeah. So our field of view right now is just 45 degrees, and when we want to zoom in, we'll be changing it. All right. That's that. And now for constructor, we're going to want to do just camera, and we're just going to initialize it with GLM vec3 position. Just like that for now. And next we're going to have 4 different methods. 3 of those methods are going to be processing input from the user, and the last method will be outputting the view matrix. So for input, we're going to have camera direction, position, and zoom. So void update camera direction, double dx and double dy. So this will be for moving the mouse. So dx and dy is just the difference in the x coordinates and the y coordinates on the screen. We're going to have void update camera position. And this is going to take a direction, and we'll leave that type blank for now, and then double dt. And that will be keyboard input. And then finally, void update camera zoom, and double dy for the scroll. Right. And then the last thing is going to be our output. So GLM that for get view matrix. And right now what we have for the view matrix is just what we had with the translating based on x, y, and z, which we controlled. Essentially all we're doing now is we're formalizing this x, y, and z into an actual camera. Alright, that is all methods for now, and let's get into this camera position. So we need that first parameter because we can't just give it a dt, which will be delta time. We'll get into why we need that later, but we need a direction. So we're actually just going to create an enum in C++. So this is going to be enum class camera direction. We're going to have a default value for none is equal to 0. Forward, backward, left, right, up, and down. Alright, so that's just enum is usually helpful when you want to store stuff like this and just map them to a quick integer value. You set this one as 0, and then forward will be 1, backward will be 2. This is default 0, but I just want to emphasize that it is 0 for reasons that will be in a bit. Alright, and then so for the first parameter of update camera position, it's just going to be a camera direction. Alright, so now let's go into camera.cpp, and I'm actually just going to go ahead and copy all of these definitions over here. Get rid of the private. And before each one, just make sure you put the camera identifier there. So camera : in front of all the methods. So you might be wondering, why am I doing this so late? Well, today I realized that I have a bit of time, and right now is a good time for me to do this, so I might switch to doing later streams instead of 12 o'clock, 2 o'clock. It all depends on my schedule, but you know what? Right now, it's looking good. Yeah, just make sure that this is transmitting once again. I'm getting paranoid. Good on them. Yeah. Alright. Let's start with the constructor. So in the constructor, the only line we're going to have is update camera vectors. And then we also have to initialize a bunch of variables. So go ahead and allocate a couple lines. And then do the initializer. I forget it's the colon, but I forget what it's called. So we're going to have, we want to initialize the camera position. We want to initialize the world up. We want to initialize yaw, pitch, for just GLM vec3 0.0f. We'll just set it up in the y direction, so 0x, 1, positive 1y, and 0 z. The reason why I'm doing this like this and not in the class is because in the future we might want to add the flexibility to actually just customize these. So we'll just add the flexibility in the constructor to do that. Alright, yaw will be initialized as negative 9.0 degrees F. So that might seem kind of, that might make a bit of sense because if you look, I actually don't know why that is, but that's what worked. Setting it as negative 9 degrees. Pitch is going to be set at 0. And then speed will be set as 2.5f. Sensitivity is 1.0f. Zoom is going to be 45.0f, and that is the reason why is because that's our field of view right now. And then finally, camera front will be looking in the negative z direction, because what we have as of now in our little mock camera is the view port coming from positive 3 in the z direction. So if we want to look at the negative z, if we want to see the actual thing, we would say the camera front is pointing in negative z. So what we would say is camera front is GLM vec3 0.0f, 0.0f, negative 1.0. Yaw and pitch variables. So yaw plus equals dx and pitch plus equals dy. And then we want to set bounds on those. So if pitch is greater than 89.0 degrees, or 89 degrees, we're going to say pitch is just equal to 89.0 f. And then if pitch is less than negative 89.0 degrees, we just want to say pitch is equal to negative 89.0 degrees. And then at the end, we want to update to camera vectors. Alright, for position, we're going to calculate a velocity. So float velocity is equal to a float conversion of dt. Once again, we'll see what dt is in a second. Conversion of it times the speed, which we set in the camera class. And then, like I said, this is where the E comes in. We'll determine where to go with the movement. So what we're going to say is we're going to switch direction. And we're going to have case camera forward. Oh, not camera direction forward. Brake. Case camera direction backward. Brake. Case camera direction right. Brake. Case camera direction left. Brake. Case camera, I'm becoming monotone. Up. Brake. And then finally down. That was kind of annoying. Let me drink a bit of ice water. Oh shit. That was bad, but you gotta get through it if you want to stay safe in these trying times. I'm gonna blast this real quick just because it's about to hit a slapper. 8 seconds, don't worry. This song slaps. Oh my god, it's so fucking good. It's called Imposter Syndrome. If you were wondering, we're listening to the C418's One album. It's been a bit since we've listened to this on stream, but always good to go back. Alright. Now, let's actually do something with the stuff here. I actually forgot to turn something down. Oh no, I didn't. I'm good. Alright. So for forward, what we're going to want to do is we're going to want to add a vector times a velocity. So it's kind of annoying, I know, but so let's just look at this. So the point of having the front, up, and right vectors for direction is so that we can actually just add those to our position vector pretty easily. And the GLM library has made this even easier by overriding the plus equals operators. So the way we're going to do this is camera pose plus equals camera front times velocity. And the reason why this will work is because the front of the camera, if we're moving forward, we want to move in the direction of the front. I mean, I'm not speaking like rocket science over here, that's just basic shit. But anyways, this is going to add the vector value of camera front to the camera position vector, multiplied by velocity, obviously. But yeah, and it's just a little bit of intuition and a little bit of clever code there, and taking advantage of the library. For backward, we're going to say camera pose minus equals camera front times velocity. For right, we're going to say camera pose plus equals camera right this time times velocity. And then for left, we're going to subtract camera right, so camera pose minus equals camera right times velocity. And then for up, we just want to do camera up. So camera pose plus equals camera up times velocity. And then for down, we want to subtract camera up. So camera pose minus equals camera up times velocity. Alright, so that is the update camera position, and this will be with the keyboard, like I said. Alright, for zoom, all the DY is just the change in the scroll wheel. So if we do up and we scroll into whatever, positive, negative, basically what it is. Alright, so like with the pitch and yaw, sits and downs, so all we're going to say is if zoom is greater than zoom up or low, and zoom is less than 45, those are up, lower outcomes. Don't mistake that for the near and far points. This is the balance for the FOV, not the near and far points. As they zoom, I'm not zooming anymore. Zoom and zoom. Check. Oh, that's a verb. It's a French verb. Now, zoom urban dictionary. I actually don't know how that got into French, but okay. Generation Z. What is Generation Z? Up to late 90s. Alright, I'm not going to tell you guys my age, but I probably have before. Okay, sorry. Zoom minus equals dy. Yeah, well, it's minus because it's inverted. If you're scrolling in or up on the thing, it's going to give you it's going to give you a positive value. But because if you're scrolling in, you're zooming in, you're going to decrease the field of view, so you want to subtract it. And if you're zooming out, you want to increase the field of view. Alright. Else, if zoom is less than 1.0 f, we want to set zoom equal to 1.0 f. And then else, it's going to be greater than 45, that you don't need a statement. Just like that. Zoom is equal to 45.0 f. Alright. Now, for the get view matrix, what we're going to be doing is we're just going to return a GLM function that is GLM look at. I know this library has everything. We're going to pass in a position, camera position. We're going to pass in. Let me get the explanation real quick. Where is it? Look at. Here we go. So the position is camera pose. The direction of look at will be the position plus the direction of the camera, which is front. And the reason we want to do that is because vector is pointing towards 0, 0. If it was nothing, if it would be coming out of 0, 0, out of the origin if we didn't add anything to it, but because it's not coming out of 0, 0, we want it to come out of the camera, so we just add the vector of the position and the position and the direction of the camera. So that's why we do it. So that makes sure that we're always looking at where the user wants to look. So for direction, we're going to say camera pose plus camera front. And this is kind of hinting at a little bit of vectors that we've actually looked at in local and global space. So in camera space, camera front is just the direction vector. But because we're moving from camera space to a global space, we need to add the relative vector of the global origin to the camera. That's a little bit of physics too. That comes up in physics. If you take physics, AP Physics C, that comes up in having to add relative. Oh my god, my dog scared me. Oh shit, my dog scared me. I know what that meant. Based on relative vectors, stuff like that. Right, and then the last vector is just going to be camera up. And that's just an up vector. Alright, for the last method, update camera vectors. So what we're going to have to do for updating camera vectors is when do we call update camera vectors? After we set the yaw and the constructor. So we're essentially going to have to update the camera vectors of right, up, and front when we change the direction that we're looking at. And that kind of makes sense because it's going to change. That kind of makes just intuitive sense because you're changing which way we're looking at. So you want to change the vectors that represent essentially we're able to set the X, Y, and Z components based on the pitch and the yaw angles, which, like I just said, is these. I'm going to post a link to this down below if you want to take a look into some of the math of it, but it's just trigonometry, 3D geometry, actually. Alright, so for update camera vectors, we're going to want to say glm vec3 direction.x is equal to cosine of glm radians of yaw times the cosine of radians of pitch. I think I've touched on this before, but why do we convert it to radians? Because this cosine function takes in radians, and yaw and pitch are in degrees. Alright, direction.y is equal to sine of the pitch, that's just that, glm radians of pitch. Direction.z is equal to sine of glm radians yaw times cosine of... That doesn't make any sense, actually. Did I get that right? Oh. No, yeah, that's right. The sine of the yaw times the cosine of the pitch. glm radians pitch. Okay. And then we're going to want to normalize this and set it to the camera front. So camera front is equal to glm normalize direction. Let me actually just... Alright, so we set camera front, now we need to set camera right and camera up. Because we're in a right-handed coordinate system, we only need the camera front and the world up, which will stay constant. That's why we have a world up variable, because that's just a constant. You can't change which way is up on the Earth, or in your world. If you could if you wanted to, but for the sake of making it realistic, we're going to want to keep that constant. So we're going to say camera right is equal to the normalized vector of the cross product between the front and the up vectors. So glm cross, you might remember a while ago when we did our video on vectors, the cross product is a vector-vector operation that returns non-vector. So cross of camera front and world up. And then camera up is a glm normalize of the cross product between camera right and camera front. Stress. All right. Now, yeah, so that's our camera class. That's the entire camera class. Looks pretty good. Alright, so what can we do with this? Nothing yet. Because we actually have to change a couple things in main.cpp, and then we're going to have to process, we're going to have to route the input from the main class to the camera class. So the first thing we want to do in main.cpp is get rid of x, y, and z. Don't need that. Get rid of mouse transform. Don't need that. And then under joystick, we're going to create our camera. So camera, and then we're going to be accessing the static variable. So camera default here. I didn't include this one. Go ahead and make sure to include an IO. Default camera, and we're just going to initialize it with a position glm vec3 of 0.0f, 0.0f, and 3.0f, just like we did with our other mock camera. and then add in the process input, we're just going to go ahead and add a parameter that's double delta time, because that will be needed for parameters. Alright, next thing we want to do, go down to the process input and add that second parameter, so double delta time, and delete everything that we have right now over here. Delete everything of move camera, because we don't want it right now. Alright, third thing we want to do. We need to set a couple things in GLFW. Apart from, we just set the callback earlier, and now we need to, let me just find it, sorry. There was a line of code that allows us to capture the cursor in the middle of the screen, and with that we can lock it there. So that's how you get effects like in any FPS where you don't see a cursor in there, 1, and 2. You're pretty much just moving the middle of the screen. Okay, so GLFW, go to where we set the mouse, the cursor position callback, and we're going to say GLFW set input mode. We're going to pass it a window. The mode is going to be GLFW cursor, and then GLFW cursor disabled. So what this is going to do is just disable the cursor, so we can't see it. Go down into your main menu, get rid of these X, Y, and Z, because we don't need them at all. There's an error with the process input because we haven't passed delta time. We need to calculate delta time. So what we're going to say is double current time, GLFW get time. We're going to say delta time is current frame. Current times minus last frame, and then last frame is equal to the current time, and that's just the classic swap. And then for the process input, it's passing that second variable delta time. We can get rid of this setback further. Comment out this view for now because we're going to be changing that. Well, actually, you can just go ahead and replace this with camera, default camera, dot get view matrix, because that's what it's going to be in the end. I'm not going to run it yet just because there's, well, do we want to run it? I feel like I can get a bunch of errors. Yeah, let's run it. There's going to be no input though. Hopefully it works. Why can't I not? There we go. So you see, it looks like what we had before, and I'm moving my mouse right now, and it's not changing anything. I mean, it didn't change anything before, but you get the point. Okay, now, let me just make sure I'm not missing anything. Okay, so in the mouse class, so delete X out of the camera class because we don't need that at all anymore. In the mouse class, we're going to go ahead and create a new callback. Because like I said, we're going to be controlling the zoom of the camera and we need the mouse wheel for that. So the mouse class is say static void mouse dx and dy, that's used for trackpads, because, or is it? Yeah, because on a trackpad you can like kind of put 2 fingers down and scroll to the bottom left. So I guess that's scrolling dx and dy. So we'll only be using dy for the zoom. And then in mouse.cpp, let's go ahead and call back for next. All this is for mouse wheel callback. We're going to leave that empty for now. And then in main.cpp, we need to set that as our callback. So go to where we set the other mouse callbacks, which is over here, and we're going to say glfw set scroll callback, and we're going to say window and mouse : mouse wheel callback. Alright, next in mouse.cpp, we're going to approach each of these one at a time. Or each of the input methods one at a time. So what we're going to do now is we're going to do the direction. So that'll be mouse position. So get rid of all this bullshit that I talked about with normalization, because that doesn't matter anymore. That was just my bullshit so I can test the matrix transformations. But that's pointless for now. Is equal to underscore y, and we're also going to need to store a couple more variables. So go into mouse.h, and we're going to create 4 new variables. So static double last x, static double last y, static double dx, and static double dy, and then static bool first mouse. That'll come in later on. And then we just want to be able to retrieve dx and dy, because that's all that matters. So static double get dx and static double get dy. Alright, and then in mouse.cpp, just go ahead and define those get variables or the get methods. Double mouse get dx, and that's just going to return dx, and same for get dy. So double mouse get dy, return dy. And then we also have to initialize all of these variables. So what we're going to say is double mouse last x is equal to 0, double mouse last y is equal to 0, and double mouse dx is equal to 0, and double mouse dy is equal to 0, and bool mouse first, I'm sorry, is equal to 0. Okay. That was a lot. Hopefully you guys got all that coded. But all we did was just define a bunch of variables. Alright, now back in cursor position callback, what we're going to say is if first mouse. And the reason why we want to do this is just to test to see if it's the first change of the mouse, because if we don't detect that, then we're going to get some massive, so we have our last x and last y set to 0, 0, so that would be in the top left. If we didn't have this first mouse check in, and we started our program and the mouse was in the middle, that would be like that would be 50% of the screen dx and dy, so that'd be like, that'd be 860 for x and 540 for y, and that would result in a massive camera movement, and you don't want that. So we're just going to test to see if it's the first mouse movement. We just want to set them equal to each other. So last x is equal to x, and last y is equal to y, and then first mouse is equal to false. Okay. Next, we just want to see dx is equal to x minus last x dy is equal to last y minus y, and once again, this is because the y coordinates are inverted. So the top left is 0, 0, and the bottom left is 0, whatever the great, and then with the positive y, we want it the other way around, so we're just going to negate the difference, which is just like doing the opposite. Alright, and then we want to set the last x equal to x and last y equal to y right now. And then camera, I need to include camera. In the top, go ahead and include camera.h, and then just go ahead and say camera default camera dot update camera direction dx dy. Okay. So yeah, that's that. And what we can see now is, let's run this. Oh no, build errors. Oh frick. Oh yeah. In mouse.h, include glad first. Before you include glfw3. It freaks out if you don't do it. It's going to send the IRS to your house if you don't do it. That's the last thing you want, especially in these times. Oh shit. Oh crap. Hold on a second. See, this is weird because it's putting the output in my second monitor. I don't really want that. Okay, so we see here we have our thing, and I'm moving the mouse. Ooh. It's very scary. Fuck. Oh my god. Oh shit. It's like he has Alzheimer's. Holy fuck. I can't make that joke. That's where did he go? Where did Obama go? Fuck. Where did he go? Where the fuck did Obama go? Oh, I found it. Alright, it's all good, don't worry. Alright, okay. So yeah, that's the mouse. And then we also need to set the wheel callback. Because once again, that's just something. So in mouse.cpp, just go ahead and say camera, in the mouse wheel callback, just say camera default camera dot update camera zoom, and just pass in dy, and let's see how that looks. God damn it, it keeps popping in the wrong fucking window and I don't want that. Alright, you zoom, is it working? Hold on, it wasn't working. Someone's gonna answer me. Shit. Crap. Why is this? This is actually kind of confusing. Let me go ahead and just print out. Don't worry about anything yet. Alright, so it's detecting it. It might be a camera problem. Update camera zoom. Oh, that's right, because we don't wait. Oh, yeah, that's why we forgot to change the thing in the main file. So in main.cpp, would go down to where we set the perspective and change the 45.0 float to the field of view from the camera. So we're just going to be camera, default camera, dot zoom. And now it should work. What you have to do? There. Oh, I didn't show you guys, I'm sorry. Oh, come on, I lost it. This is getting really annoying. Alright, let me zoom out. Oh, there he is. See that? Zooming out and then zoom. Ooh, we're so close. Oh. What you will also see here is that if when we zoom in, we decrease the field of view, so that near frame becomes a lot closer, or that near frame goes a lot further away. So you see, as I'm zooming in, it's practically gone. Yeah, that's all. You can look at as per usual, you can always change it to yet. We will though, because I did find one really bad thing, but for now it's okay. So what we're going to say is, in our process input method, we're going to go ahead and, so we're going to get the direction. So we're going to say camera direction is equal to camera direction none. And next we're going to test for the 6 keys. So WASD, then the spacebar, and the left shift key. So if keyboard key GLW key W, that's pressed, we want to go forward. So direction to camera direction forward. And I'm just going to copy this and paste it 5 more times. 3, 4, 5, 6. And then we're just going to change it to W, S, D, A, space, and then left, shift. And then we're going to say, instead of forward, we're going to change the forwards to left. Not left, sorry, backward. D is to the right, A is to the left, space is up, and shift is down. Okay, now, the reason why I wanted to emphasize the direction is because I can do this now. If direction. I'm sorry, that really probably hurt your ears. I would like to apologize about that. I would really like to apologize. That was uncalled for. Anyway, what I wanted to get, or actually, there we go. So if the integer value of direction is 0, that's going to pass false. So that means that there's no direction change, or no movement. So we don't have to update the camera position. But if there is, it's gonna be a positive integer, and that's gonna be true. So if it is, we're gonna say camera default camera update camera position, and we're gonna pass in direction and delta time. Alright, let's test this out. if you have epilepsy, I'm really sorry. You should not be learning how to do graphics if you have epilepsy. I would like to apologize though. Do I have to put a disclaimer? Hold on, let me put a fat disclaimer. Disclaimer. Don't watch if you have epilepsy. I'm sorry if that was offensive. Probably was. Once again, I should stop. Okay. So yeah, I can stop the video right here, but I'm not gonna leave you guys blue-balled. I'm gonna give you guys some satisfaction. I hinted at something earlier about multiple cameras, and I never really followed through on that. So what I want to do now is I want to add that capability. So in camera, we're gonna add another variable, static camera secondary, and then we're gonna have a boolean to store static bool using default. And then in camera.cpp, or actually in main.cpp, go to the top. We want to initialize that camera, so camera secondary, and we're gonna put it at 0, or we're gonna put it at 5.0f, 5.0f, and then 5.0f, and then camera or bool camera using default is equal to true. So we want to start as default. Okay. Now in main.cpp, we now need to change a couple of things. Because if we're not using the primary camera, we don't want to change that position. So we want to determine which position and which data to retrieve based on what camera we're using. So first change is in the main link. Go to the projection, or go to the view first. What we're going to say is camera, we're going to do a ternary operation. Camera using default question mark. If that's true, we want to get the default. Otherwise, we want to get the secondary. Camera secondary. And then for the zoom, we want to do the same thing. So camera using default. I'm actually just going to put this on as a separate one just because it's really bad. So default camera zoom, otherwise do camera secondary. Alright, and then the final change, the second and final change will be in the input. So if camera using default, we want to update that to default camera position. Move this line over there. Otherwise, camera secondary update position. Alright. Okay. Next change will be in the mouse because we want to do the same thing with the update camera direction, because we don't want to do that for the default if we're not on the default. So in mouse, we're going to say if camera using default, do it for the default. Otherwise, camera secondary dot update camera direction dx and dy. And the same thing for the zoom. So if camera using default, and then else camera secondary update zoom dy. Alright, so now we have a second camera in place, but that's not going to do anything for us because we can't change between the two. So we're I'm just going to assign a single key to it. It's just going to be the tab key. So in main.cpp, in the process input method, we're going to go ahead and say update camera, and we're going to do if keyboard key of glfw key tab camera using default, and we're just going to reverse it so it's equal to the opposite of camera using default. Alright, so let's go ahead and test this out. Alright, so I need it. God, Obama, get your ass in the middle of the primary screen. Ooh, shit, dumbass bitch. Let me actually just make this thing bigger. Ah, you see, so that also works. Okay. Now, let me press tab. You see it goes elsewhere and it's really far away. But you see it's looking in the same direction. We can customize that direction if we don't want to. And you see, yeah, that's a problem we're going to have to fix. So let me move this camera. Registered the tab key down every time we looped, so it kept reversing. So in order to combat that, in order to send the troops out and just actually defeat the problem, we're going to have to modify our mouse and keyboard classes. The reason why is because, like I said, it just constantly reverses it. But before, let me just get some more water real quick. I'll be right back. Alright, let's go into our keyboard class. So the problem that we have right now is we're sending back a true for key every time that it's just registered as down. And it doesn't change until a different action happens to it. What we want to do is we might only want to do an action once, and that only happens when the key is pressed, and only at that moment. So what we're going to have to do is we're going to have to create a new, another array of Boolean variables, and we're going to say static bool keys changed, and just like that. Must have been some gas in that nice room. Did I say I was getting water? I did not get water. I was getting this room. Don't worry. I'm staying safe. Alright, and then we're going to create 3 new methods. So, static bool key change into key, static bool key went up into key, and static bool key went down. Alright, and then in keyboard.cpp, we have to initialize the array. Say bool keyboard bool ret is equal to keys changed at key, and then we want to set keys changed to false, because once we get it, it happened, so we don't want it to return true again. So what we're going to say is keys changed at key is equal to false, and then return ret. Now, you might be wondering, well, when is it going to reset to true? Well, we have to add that in the key callback, and what we're going to say is keys changed at key is equal to action does not equal glfw. Believe it or not, glfw repeat. Believe it or not, glfw will send an action to our key callback when a key is held down for some number of seconds. Anyway, yeah. And if it is repeat, then that action has been present for some time, so we just want to say false. Keyboard key. Next we also, not key. Key change, I'm sorry. The second up is the change. Next up is bool. Key went down. What we're going to say is return that the keys that value is false, so not keys at key, because we want to, keys at key, positive keys, sorry, I missed one. We're going down, so we want to let's group down. And the key just changed, so key changed, and this will reset the value to false if it's true. And then we'll also set it to false if it's not bool, keyboard, key went up, and return the opposite of keys, so keys at key, and key change. That's pretty much the same thing. Right. So we now added access to, let's go ahead and test this out, and then I can solve some tricky ones. Alright. So I'm going to press tab. Because we never changed it to main earlier. That's why. Right, main.cpp. Change the method from key to key went down. So I'm holding tab and it's not changing that. And when I release it, it doesn't change. When I hold it again, it doesn't. At some point, OpenGL is going to start sending the release, so or sending the repeat, and we can actually just see when that is. Run this out and need the terminal for this one. I can bring it. Alright. So I'm going to hold down this tab key starting now. And you see after like a second or two, it then starts to repeat message. Alright, so we're going to have to do something similar for the mouse. This is the last thing we're going to do, so if you don't want to watch this, if you want to just leave me and go watch Coding Babes, that's all fine by me. I mean, you gotta believe, you gotta do what you gotta do, but I don't know. just stay here. Alright, we're going to have to do the same thing. So, get our another Boolean array, so static bool buttons change. We're going to say, we're going to add 3 methods, so static bool button change each button. You can actually get rid of the underscore in front of that. You don't need it. We're going to static bool button went up each button. Static bool button went down. Alright, copy all these over. Mouse.cpp. And the mouse identifiers. Replace your semicolons with curly braces. And then remove the static identifiers. That's kind of fucked up. Alright. Okay. Next in mouse.cpp. Initialize that array. So bool mouse buttons changed at GLFW mouse button last is equal to all zeros. Just like that. Alright, now for the methods, we're going to do the same thing. So in the mouse button callback, what you're going to do is buttons changed at button. Oh, I'm sorry. I realized why we were having that input stutter. It happened when I discovered let me just do this and then I'll talk about that for a second. Correct. So buttons changed at button is equal to action is not equal glfw repeat. Okay. So the reason why we were getting that stutter where it just stopped was because when GLFW sends in an action of repeat, that doesn't equal GLFW press. So this is going to be set to false. And because it might be up at that point, it's going to get confused and go all over the place. So what you have to say here is action does not equal GLFW release and action does not equal glfw repeat. Wait a minute. Hold on. Does this logic work? So let's go ahead and test this. So let's say we were lifting the button up or letting the button go back up. Action does not equal glfw release. So that's false. That's automatically false. If we push it down, action does not equal glfw release. That's true. And action does not equal glfw repeat. That's also true. Hold on. We're gonna have to add an extra level here. We're gonna go deeper, guys. Don't worry. So, say if action is equal to glfw release. What we want to say is, or if action is not equal to glfw release, else just say buttons at button is equal to false. Oh, I don't have Chrome, guys. Don't worry. That's just something I've thrown. Don't worry. Alright. So if action does not equal glfw release, so that means that it's either repeat or it's press. So what we want to say is if buttons at button, so if it's already down, we don't want to change it. So we wanted to only change it if it's not down. So if not buttons at button, we want to say buttons at button is equal to true. Okay. So yeah, so let's go ahead and test this, or let's look at this. If we push the button down, we're going to get a GLFW press. So that's not equal GLFW release, and that's going to go into this loop here. Buttons at button is false, so that's going to go into here, and then we said it's true. That's right. Now let's say we were holding it. Now GLFW is not, the action is not release. Buttons is true, so this will not pass, so that's fine. And then yeah, so that all works. Good. All right, so now let's just input this into the keyboard one, or actually let's just finish the mouse class first. So button changed is going to be the same thing. So bool ret is equal to buttons changed, or buttons changed, yeah, at button placeholder. We're going to say buttons changed at button is equal to false. Return ret. The reason why we need this placeholder is because this could be true, or this could be false, so we don't always just want to return true. So button went up. We're going to say return not buttons at button and button changed. Buttons changed, or not, call the function button changed at button. I said button too many times. Button, Benjamin Button. If button went down, return true for buttons, and button changed at button. Okay. Now let's go ahead and translate, or let me just make sure you guys get all that stuff down. That was the same thing that we did in the keyboard. Now, for a mouse wheel callback, or wait a minute, no. We have to put this if statement in the keyboard because that's just something that we haven't done. We're gonna end up doing this for the joystick, but I'll just do that on my own. You guys don't need to see it because it's actually gonna be the exact same thing as these. I can't do these other ones. Okay. So replace the first line of the key callback with the paste, and then just change all the buttons to keys, and the button to key. So change all occurrences of buttons, or all occurrences of button to key. And what we should get now is no errors, and then finally, get your ass over here. He's just so shit. Alright. Oh. No input stutter, boys. There we go. That's what we want. That's what we want. And I'm pressing right, so we're essentially going around in a circle. Because I don't have Parkinson's. It's okay. I just can't keep the fucking mouse. Let's zoom in. Whoa. Yes, this is what I was talking about. Oh. I just pressed the audio key and that's what fucked up. That's great. That's too loud, I'm sorry. Yeah, so that's let me show you the joystick. Don't worry about it. God. Wait a minute, I actually can't. Wait a minute. Oh yeah, I can't do it for the joystick. You can't do it for the joystick because there's no callback. So that's gonna be kind of weird. You might have to create your own callback. We might explore that in another video. So yeah, that's all I